here we're going to build off a previous video called Alkenes and talk about alkenes. So if you haven't seen alkanes, go back and refresh yourself with that, please. And then we're going to build on the alkenes here. Again, these are hydrocarbons, so they only contain hydrogen and carbon atoms. Again, carbon tries to make 4 bonds. The ene part of this means it has 1 double bond. Okay, and this is between the carbons. There's 1 carbon double bond. And again, you have the same prefixes. So meth means 1, eth means 2, prop means 3, bute means 4. I'm going to put another one here. Pent means 5. So let's put the enes on. Ethene, propene, butene, and pentene. They're all part of this alkene family. Now, the interesting thing here is you can't have a methene because the double bond is between the carbons, and meth means you've only got 1 carbon. So you can't have a carbon-carbon double bond. So methane does not exist because there's no carbon-carbon double bond. So pause it now, try and draw the rest. Try and draw ethene, propene, butene and pentene only using the information that I've given you and see if you can work it all out. So, ethene, 2 carbons, carbon-carbon double bond, and then every carbon has 4 bonds. Here, the carbon's already got 2 bonds. Okay, this carbon's got 2 bonds and this carbon's got 2 bonds because it's a double bond. So I only need 2 hydrogens on each carbon to make it up to 4 bonds. So now this carbon's got 1, 2, 3, 4. This carbon's got 1, 2, 3, 4. Happy with that. Propene, carbon, double bond, carbon. Now what lots of people do is do another double bond to the 3rd carbon. Okay, but this is incorrect. It's only got 1 double bond in it. Okay, so this carbon has got 2 already, so let's add 2 carbons on. Again, this is a part where other people make mistakes. This carbon has got 1 bond, 2 bonds, 3 bonds already. So it only needs 1 more hydrogen. Now this carbon needs 4 in total, so we need 3 around that. So this propene looks a little different to what you've seen before, but it has to follow these rules. Okay. Finally, next one, butene. 4 carbons, follow the rules. So 2 hydrogens on that one, 1 on that one, 2 on this one, and 3 around that. And finally, pentene with 5 carbons. Well, 1, 2, 3, 4, 5. Let's draw the hydrogens on. Run through and check. Has this carbon got 4 bonds? Yep. 1, 2, 3, 4. Yep. This one, 4, 4, 4. Happy with that. Now what we're going to do, we're going to look at the symbols for these. So ethene, well, ethene has 2 carbons, so C2, and 4 hydrogens, H4. Propene, it's got 3 carbons, and hydrogens, count them up, 6. Butene, 4 carbons, count the hydrogens, H8. And pentene, count the hydrogens, will get you this. So just like before, we can come up with a general formula for alkenes. Okay, so can you work out what this is? If I have n number of carbons, how many hydrogens do I have? Well, to turn 2 into 4, I double it. 3 to 6, double it. 4 to 8, double it. So if I have n number of carbons, I have 2n number of hydrogens. So for example, if I've got 12 carbons, I will have 24 hydrogens. There is another slight difference that makes this slightly more complicated, and I'll use the example butene to show you. So it doesn't actually matter where you place the double bond. For example, in the butane example, I put the double bond between the first carbon and the second carbon. But actually, the double bond could be between the second and the third, as long as I'm following this rule that I've only got one of them. So I could have this carbon, 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 carbon. I've got 4 carbons, so it's still bute. It's an ene because it's got one double bond. Now this carbon will have to have 3 hydrogens around it. This carbon will only have 1. This carbon will have 1. This carbon will have 3. Does it still match this formula? Well, it's still got 4 carbons, yes. Has it still got 8 hydrogens? Yes. Is it a hydrocarbon with hydrogen and carbons only? Yes. Has every carbon got 4 bonds? Yes. Is there 1 double bond? Yes. So these butenes, they're both the same. They have the same formula. They've just got slightly different structures. And we call those isomers. So isomer.